Yes friends, as part of this session, let us understand overriding of hashCode method and equals method. Getting overriding of hashCode method and equals method. One important thing why we have to override hashCode method and equals method. Getting guys, why we should override hashCode method and equals method. We'll discuss, okay? We'll discuss each and everything from the scratch, okay? Overriding of hashCode method and equals method, guys, okay? Equals method, okay? Having argument as what? Object. And some of we guys even spell this one as the contract between equals and hashCode. Okay, let us understand what exactly exists in this overriding of hashCode method and equals method. Okay, observe. For a while I want to talk about hashing related data structure. Just the picture, okay, just the skeleton, than that nothing. Okay, let me tell one thing. Let me tell the hashing related data structure. Hashing is one of the data structure where we are going to store our data for fast retrieval. Even this day, the fastest data structure to retrieve the data is what? Hashing related data structure. Okay, I mean with order of 1 you are going to retrieve the data by using the hashing related data structure. Okay, now observe, in hashing you'll be having blocks. Getting, it is strictly 2-dimension array. It is strictly what? 2-dimension array. Getting, 2-dimension array. And this each segment or each block is called as bucket. Getting, it is called as what? Bucket. Getting, as it is called as a bucket. Okay, this is what? Hashing related data structure. Getting, you are going to organize the data, that is you are going to store the data in a particular way according to our requirement. Getting, according to our requirement. Whenever you save the data within this hashing related data structure, you are having one restriction, you are having one what is that? One condition. What is that condition means? Observe, duplicate. Getting, duplicate values are not allowed. Getting, duplicates values are not allowed. In order to expect a well defined functionality from this data structure, you have to follow one principle. What is that principle? Duplicate values should not be stored, so that our retrieving time, observe, our retrieving time will be very fast. Think that you are saving 1 crores of records. Getting, 1 crores of records. Getting, 1 crores of records, and it is 1 2 3 4. Okay, my element called as 9,99,999 is available at one location. I want to iterate each and every element, and I have to go to the position 9,99,999. It is taking or consuming some time. Getting, so instead of doing this linear searching and linear retrieving, we have to depend upon hashing. The main aim of software engineer in a company is what? How to write an efficient code. Getting, that is what our jobs at companies. Okay, now observe here, why you have to go for hashing related data structure only? Why don't you go for other hashing related data structure? Let me give one small example so that you can feel, I mean you'll get an idea. We have to go for hashing. Getting, you go for hashing only. Okay, just I'll give one small example. Observe. Let's see that particular code. I mean, why we have to go for hashing related data structure. One important thing I want to make notice to you is an array is also a data structure where the elements are going to store in consecutive fashion, guys. Okay, in consecutive fashion, getting in consecutive fashion, let it be the values. It is also one of the data structure. By leaving this data structure, you are going for hashing related data structure, hierarchical data structure, whatever it is, getting. Now let us see why we have to go for that one. Without this knowledge, if you are using that hashing related data structures, definitely at some point of time you will face some troubles. Okay, just observe this small piece of code. Let it be class A, getting class A. Now create main method string array. Now take one array A whose size is 5 lakhs, getting 5 lakhs, getting guys 5 lakhs. So an array of size 5 lakhs is created. Okay, now observe here, I am going to store. Now initially what will be the array elements? Everything will be of 0, getting everything is what? 0. Whatever the array type, data type, that data type default value will be available within each block, getting. Now observe this part. Okay, now let me take one for loop. Okay, and take one variable, local variable. Now observe, take this point a dot length. Length is the variable, final variable which gives the length of this array. Okay, now if I is less than a dot length. Okay, now this is initialization section, optional thing. Okay, I have done initialization here, so no need to take here. Okay, now if I is less than a dot of length and I plus, now come here, assign the value for a of I. Currently value of I is what? 0. At 0th index, assign the value as I plus 1. Put 1 here and 2 here, like 3, 4, 5, 6 till 5 lakhs. Okay, now observe here. Okay, let us do this action till the last index, that is let it be the last index here. It will be as what? 499,999, getting guys 999. So here the value will be as what? 5 lakhs. At this previous to the last index, there will be an element called 499,999. Okay, now think that I am searching this 499,999 element. I have to pass these many indexes and these many values comparison also has to be done. Okay, now observe here. Now take one more for loop. Okay, and searching should be done from starting index onwards, right? Think that my finding element is what? 499,999, which is available at this block of index this one, getting. Now observe here. Okay, observe. Now let me initialize I variable to 0. Once again, I is less than a dot length and I plus. Observe here, if a dot of I equal to 499,999, getting, then what you have to do? Put element found, getting element found. What is that element? 499,999. Okay, getting. Now just do break. I don't want to do search. If my element is available at first index, means no need to check these indexes. Okay, these indexes. Now observe here. Okay, just put break. Otherwise print, what is that? Print system.out.println. What is that? Element not found at, element not found at, what is that? I, getting I. Let it get run. Okay, and close the main method and also close the class. Observe here, observe here, it will take much time to find the element which is available at this index. It will take much time. Okay, in order to take less time for execution, we have to go from this data structure to this one, that is from array to that hashing related data structure. Still you are having many data structures like binary search tree, all of these things, that is a hierarchical data structure also we are having, but the efficient one till these days what, hashing related data structure only. Okay, so let me first compile and execute this piece of code. Okay, later we go for that particular this one. Okay, you have to know why we are coming to this one. Okay, and definitely some interviewers will be asking, why can't you go for array instead of hashing? Getting? So why you are going for hashing if you are having array itself to store and retrieve the data? Such type of questions will be there in interviews. It depends upon the interviewer how he was. Okay, now observe. So let me develop that code. Class A, what is that? Let me take one static void main string. Okay, now observe here. Okay, now let me take an array of size what, 5 lakhs. Okay, 2 3 4, okay, 5. Let me take one local variable 0. Now take one for loop. I have done initialization here, no need to go and do the initialization once again. Okay, I is less than a dot length and I place. Now assign a of I what, I place 1 and come to this searching, getting I equals to 0, I is less than a dot of length, I place. Now write the logic here. What is the, if a of I equals to 49999. Okay, now observe this part. Okay, now if the element is found means what we have to do, you have to tell element is found at, okay, element, what is that element, 49999, found at which index, I index. Getting? And you have to come out of the iterations, no need to do other searchings. Okay, now observe here. Okay, if element is not found means tell that particular thing, element not found at I. Getting? Element not found at, okay, now observe, I am going to execute this piece of code and run. Try to observe how much time it is going to consume, friends. Okay, that is what our job to notice here. Okay, observe, now I am going to run the main method corresponding class, and this class has been saved with a name test, that's why test.java compiled successfully. Now main method class name is what, A. Okay, java space A. Observe this part carefully, how much time does it take to execute. Observe. Okay, observe here. Okay, element not found, our element is available which index, at this index, so it is performing checking at each and every index. Observe that part carefully. Okay, observe it carefully, how much time it is taking, still it is searching, how much time it is consuming just to search 4,99,999 element itself. It is consuming much time. Okay, observe, watch it carefully, guys. Okay, element not found at 249, and now it has come to 2 lakhs, and it is at nearly 2,70,080. It is still searching. It is time consuming process. It should not get happen in that way. Okay, observe, still it is going, still it is going. Okay, it should not get happen. Okay, observe that one carefully. Now it is going to find our element, that is 499,999, where it is available. Observe, getting element 499,999 found at 499,999 8. Okay, now observe here. Okay, observe here the same scenario. Now observe this part, guys. Okay, to search an element which is available at this index, it is taking that much amount of time. Okay, now you might be getting, what if the case if there is an element at this index? Now it will take less time. Now let me give 2. Okay, instead of this value, let me give 2. It will take less time only. Our main intention is it should take less time for end element, that is end element. Getting? That is what our job in all the companies to write the code. Okay, observe, let me put 2 instead of 499 999. Observe here, instead of 499 999, let me put here as what? Just 2. Okay, observe this part, very less period of time. Observe, yes, element found. Getting? Element found, less period of time, found at found, element not found, and it is found at first index. Okay, so in order to avoid this much big consuming time, we have to go for hashing related data structures. Okay, hashing related data structures. Here the searching will be done by using some functions. We are having n number of functions like mid square, folding, n number of techniques were there in this hashing related data structure to find an element. Okay, now let us discuss that one. So in order to save our data in this hashing related data structure, we are going to depend on this hash code and equals method. Okay, now it will be very simple to you to override. How, in which way you have to override this particular equals and hash code method? Just a minute, observe. Now let's discuss what is that. Okay, now so why we have to go for overriding hash code and equals method means simple thing, to avoid duplicates within the hashing related data structure. It is a form, that is if you want to store the data, you are having some principles. Getting? That principle is what? Hashing related data structure, and this structure is having some rules. Getting? To expect good result from this data structure. What is that means? Simple rule, duplicate values are not allowed. You should not store duplicate values. Observe here, simple thing. Okay, simple thing. If you are saving any primitive data types, I think if you are saving any primitive data types like 999, this is what duplicate data. It can understand simply. I mean, JVM will understand that 999 is what? A duplicate thing. I should not store this one here. Getting? And if you are storing 9 here, and if you are storing once again 9, it will not store this one. Why? Because JVM is having knowledge about these primitive variables. Now tell me one thing, if you are saving user defined objects, then at that time what is the scenario? Getting? That time what is the scenario? You have to intimate to the JVM the corresponding way, so that JVM will not insert duplicate value. See here, think that this is an object A containing data as what? 9, and this is what? An object A containing data as what? 9. This thing should not get stored. Getting? This thing should not get stored. Okay, JVM should not get stored that object at that bucket. This is called as what? Each segment is called as what? Bucket. Getting? Each segment is called as bucket. About this in detail we will discuss at collection framework. Okay, no need to worry, but whatever the knowledge required to you guys to understand this hash code equals method overriding, we will discuss. Okay, now observe. So how to avoid those duplicates means simple thing. You have to override hash code and the equals method. Okay, hash code and the equals method, guys. Okay, observe here, why only hash code method and equals method? Why only hash code method and equals method you have to override? Why can't you override what is that wait method, notify method, all of these things? Why you have to override hash code specifically and equals method? Simple thing. Let me tell one thing. here saving principles, getting the storing principle of data within this hashing data structure is different. You are going to use n number of techniques, getting n number of techniques. So there the technique will be using index. This is strictly an index, this is strictly an index, and whatever the values you are going to store here will be attached to this in this way. If you do observe all of these things, it will be as what? Two-dimension array, getting two-dimension array. If I invert this, observe here, if I invert that particular thing, 0, getting 0, 1, 2, 3, 4, 5, 6, 7, okay, 4, 5, 6, 7. At 7th index, I am having some single dimension array. What is this? Two-dimension array, getting? So two-dimension array itself having some principles to store the data, observe, to store the data, and that principles on this two-dimension array forms a data structure called hashing data structure, getting? Hashing data structure. Okay, now observe, let's go and discuss this one. What the important thing you have to do, okay? What the important thing you have to do here, okay? So here we are having one principle. What is that principle means? Let me tell. Simple principle, use this one as your guide, okay? So that other than this principle, whatever the scenario, getting for, I'm going to tell one small principle, that is one logic or one statement, okay, overall logic. Other than this scenario, if there exists any object that will be stored directly, that will be stored in these buckets, okay, in these buckets they will get stored, okay. And one more important thing, it is not having any restrictions. These segments are not having any restriction, that is buckets are not having any restrictions. It can be from 0 to 10,000. It depends upon the company how much data they are saving, okay. Now observe. So what is that means? Simple thing, two objects, getting two objects of same type, getting of same type, two objects of same type, let it be capital A, let it be A, and this one be as what? A1. Two objects of same type, and observe here, same type and same data, getting two objects of same type and same data, getting same data, let it be I equals to 99. I equals to 99, guys, okay. I equals to 99, I equals to 99 is the data within this object, getting this object data is what? 99, and this object data is what? 99, getting 99. So two objects of same type, of same data should not be placed, should not be, of course, observe here, this object data is same or not? Yes, they are same. So you should not place the two objects having same content, getting same content. I equals to 99, this is what? A1, this is A type, this is also A type. You should not place this object, getting it is waste, getting waste of saving that object at memory, getting. So two objects of same type and of same data, that is and of same data should not be saved, getting should not be saved within the hashing related data structure, getting should not be saved at hashing related data structure, getting two objects of same type and of same data should not be saved at hashing related data structure. And one more very important thing, here you are going to save the data based on these indexes, guys, okay. These and all what? Indexes, getting indexes. Index is in number, that is integer or some other number. It is purely an integer. Do we have any 0.0, 1.0, 2.0 as the index? No, you are not having index as floating point literals. Okay, it is what, purely an integer number only. Now observe here, to achieve this particular condition, to achieve this particular principle, I mean this hashing related data structure rule or the constraint, two objects of same type and of same data should not be saved. Now my question, if you are following the earlier sessions perfectly, you will answer to this one. Now let me know, what will be this object address? What is this object address? Different, 001. And what is this object address? 0002. Okay, observe, nothing to by heart. Okay, think yes, origin concept must be there in your brain, and you can derive from that idea each and every concept. Okay, observe. Now, an approximate integer value of address is what? Hash code. Approximate integer value of address is called as hash code. Let it be the hash code 1116. Getting? Let it be approximate integer value of this address is what, guys? Hash code. Getting? Hash code. Now observe, this address approximate integer value, this value is what? Hash code. Getting, guys? Hash code. Okay, now approximate hexadecimal string value of address or hash code is what? Our reference. Our reference. Guys? Our reference, that will be here. Okay, AAF, and this one will be as what? AF. Okay, now that's why this A is referring this AF. One more important thing, hello mister, where is the class for A? Okay, no need to worry, here it is, class A. Getting? Class int I equals to 99. Okay, public static void main string array, create an object A equals to new A. Okay, A1 equals to new A. Okay, now this is the class for this particular memory, I mean objects memory representations. Okay, now observe. Okay, now so because of these two instructions, these two objects happen, are created at memory. Okay, now observe this part.